Earlier in the chapter we discussed how SIP is extensible. We looked in principle at presence, how one party subscribes to the present state of another to be notified when a change in event state occurs, the event here being the other party's registration. But presence is just one of many event types, including the message summary event touched on in the last lesson. In this lesson we'll step above presence and message summary and look at event notification generally. By the time we're done, you should understand the principles of event notification, the difference between peer-to-peer notification and centralized composited notification, how event notification uses subscribe, notify and publish requests in its signaling, and how different events are described through packages called event types. Okay, here is entity Y. Over time, different events will occur, each with different characteristics. Oh, there's one now. Let's see, its name is Event 1, and it has just one characteristic, that of colour, this particular one being red, although from the description it seems it could be red, green or blue. Okay, another one. This one's called Event 2, and look, has two characteristics, mood and value. This one's mood is happy, it could be happy or sad, and its value is 87, although it could be any number between 0 and 100. Here's entity X, a newcomer to event notification. Now, X wants to be notified whenever event 2 occurs at Y, including its mood and its value. He's not interested in event 1. So, X gets busy and constructs a SIP subscribe request. He knows it's through the subscribe request that one entity asks another to be notified when something happens. Accordingly, he addresses the request to Y and adds all the regular SIP headers we know and love. To Y, from X, X's contact address, so Y will know where to route subsequent requests, particularly the notify requests. X is via, so Y knows where to route responses, and a call ID and CSEC for identification and sequencing. There's no media options, so content length is set to 0, right? Sending the subscribe. A moment later, X is surprised and somewhat disappointed to receive a 400 bad request response. What was wrong, he wonders. Well, did you notice? Take a moment to have a think and press play when you're ready. What was bad about the subscribe request? Or perhaps we should say, what was missing from the subscribe request? What was missing? Although Y knows X wants to be notified of events, he doesn't know which one, Event 1 or Event 2. Both events occur regularly at Y, both of them having different characteristics. So which is X subscribing to, and is X ready to parse Event 2's data? Does he know what form Event 2's status update will take? Now, this is a good point to discuss event types. Event notification operates on two rule sets. There's signaling, following the rules of SIP to construct, send and process requests and responses, and there are separate event rules defined for each type of event. Now, these event-specific rules are packages that describe the event name, its characteristics, and how those characteristics will be communicated. They're known as event types. In real life, event types are registered with IANA.org. You can see the message summary event type that we discussed earlier. Each type's described in minute detail with its own RFC, defining the event name and describing the event characteristics, including the format of the data, perhaps as SIP headers or perhaps as SIP payload. On first reading, one might think that event packages are actually SIP extensions. They're not, but they feel like it. So, back in the analogy, Event 1's package name is Event 1, and it just has one characteristic, its colour, which could be red, green or blue. And its state will be reported in a custom SIP header called Event 1 Color. Event 2's package name is Event 2, and it has two characteristics, its mood and value. Event 2's authors decided it would be best to report changes in the notify payload rather than in custom headers. Accordingly, they defined a new content type, application/event2 plus XML, which, when understood, enables others to parse and extract the notification data from the XML payload. Ah, now I understand, says X, and tries again, adding a new header to his subscribe request, the event header, including simply the name of the desired event as described in the package. This time, receiving the request and finding it acceptable, Y returns a 200 OK to confirm successful subscription and an immediate notify request to notify X of event 2's current state. Reading the notify and seeing content type application/event2 plus XML, X knows which parser to use and finds that event 2 is happy and is valued at 87. Y also adds X to his list of subscribers, also known as watchers. A moment later, when an event 2 occurs, Y checks its list of watchers and constructs and sends a notify, similar to the last one, but with updated event characteristics. So, to emphasize, event notification operates on two levels, a signaling level and an event level. Each event type has its own event package, detailed descriptions, separate RFCs that define the event and how it should be described and interpreted. It's a good approach. It future-proofs event notification. On finding a new need, a new event about which to keep others updated, we just author a new event type and register it with IANA. All event types use the same standard SIP signaling, but convey different data within those standard signaling messages. So here are the current registered event packages. Looking at Reg, we see from its RFC that it's an event package for registrations, and that where a user agent would like to be notified of changes in registration state, this event package defines a mechanism by which they can request and obtain such notifications. Scrolling down, we see the event package name is simply Reg and should appear in the event header in subscribe and notify requests. Down in section 471, it describes the event's characteristics, specifically its state. There's init, being not registered, active, being registered, and terminated, or no longer registered. Back up in section 4.5, we're told that all subscribers and notifiers must support content type application/reginfo plus XML. In other words, must know how to parse the special XML in the notifier that describes registration state change. It even gives an example call flow showing the initial subscription, including the event name Reg in the event header, the returned 200 OK, and the immediate notify that reports current event status. Inside the notify, we see again the event type Reg, but also now the content type application/reginfo plus XML that tells the subscriber which parser to use to read the payload. Because I've studied the event package, I know to look for the registration AOR state equals line and see that this one's set to init, or in other words, Joe is not currently registered. Then, sometime later, after Joe registers, the registrar, having noted a registration event has occurred, updates the subscriber with another notify. This time, the registration AOR state equals line tells me Joe is active, or in other words, registered. Note how the reg event package also defines that his contact address is included. Look through any of these event packages and you'll see similar things: the name of the event and details of event characteristics and how those characteristics are reported. So the event notification scenarios we've seen so far have been peer-to-peer scenarios, with one party being the subscriber or watcher and the other being the notifier, more formally known as the presence agent. Now, this peer-to-peer model is great for scenarios where only small numbers of subscribers are watching events. Scenarios like the call completion event, where after dialing and finding the callee already busy in a call, a user agent subscribes to be notified when the call completes and the callee is once more available. Another model, perhaps one more suited to greater numbers of subscribers, is the one described in RFC 3903, the Session Initiation Protocol extension for event state publication. It's a centralized composited model that uses a dedicated event notification server that brokers multiple event types between multiple entities where those events occur, entities in this model known as presence user agents or PUAs, and multiple subscribers, watchers, the entities who subscribe for notifications. The presence agent, the dedicated presence servers, also known as the event state compositor or ESC. The event state compositor keeps a repository for all the different event types that it supports. Then, when an event occurs, the ESC records the presence user agent's address and all of the current published event state. Now, this happens for every event. The ESC records the PUA's address in its event type repository along with the published event state. On the other side, the subscribers, rather than subscribing directly to a PUA, subscribe instead to the ESC. Receiving the subscribe request, the ESC checks the requested event type and opens its corresponding repository. Next, it checks the PUA that the subscriber is subscribing to, opens the list of that PUA's subscribers, and adds the new subscriber to the list. Next, it sends a 200 OK to report successful subscription, and then immediately a notify addressed to the subscriber on behalf of the PUA and including the current event status data from the repository as defined by the event type. Receiving the notification, the subscriber now knows event 1 has occurred at SIP 111 and that its new status is red. Interestingly enough, so far the signaling for centralized event notification is the same as peer-to-peer event notification, in that the subscriber subscribes to an event, the presence agent, albeit an ESC this time, responds with a 200 and a notify to report current event status. The big question for me now is, how do presence user agents publish event state changes to the ESC? Well, they do so with another SIP extension request, the publish request. Now, note 3 interesting things. First, the PUA sets its own address in the request URI. Second, it declares the event type in the event header. And third, it includes the event's status as prescribed by the event type, in this case a custom header in the SIP message. Completing the call flow, the ESC reports successful publication with a 200, then notifies any subscribers, all of which should respond with a 200 to report reliable delivery. So, if event 2 occurs at SIP 222, the 222 presence user agent creates and sends a SIP publish request to the event state compositor. Seeing event 2 in the event header, the ESC opens its event 2 repository, goes to the PUA's details and compares the published status with the stored status. If different, it replaces the old status with the new status. It then looks up all of SIP 222's subscribers and for each one creates a SIP notify request, including the recently published event status, before then sending the notifies to each subscriber. Okay, that's a brief intro to event notification. In summary, a subscriber subscribes to a presence agent to be notified when an event occurs. Different events are described by event packages, each event type having a defined name and format for presenting event state data. The use of event packages future-proofs event notification, allowing standard signaling to be reused by new and different events. There are two event notification models. The peer-to-peer model comprises subscriber and presence agent. The subscriber subscribes to the presence agent, stating the event type in which he's interested, and the presence agent notifies the subscriber when a change in event state occurs. The centralized model comprises subscribers, presence agent, or more specifically here the event state compositor, and presence user agents. The ESC composits or compiles event state changes from the PUAs and then notifies subscribers. Event state changes are published to the ESC through the SIP publish request. Just for your information, the two main RFCs for event notification are 6665 and 3903, and registered event types can be found at iana.org.